Lecture 9a, Lie derivative and Lie bracket. Okay, what I'll present over here is quite clear and the simplest way to derive the Lie derivative and the Lie bracket. As you will see, I will only use push forward, you see, and you see why I will explain this, but it's quite simple, see. So, step 1, setup and notation. Let phi of t be a flow of the vector field x. Capital X is a tangent vector, okay, as we showed before. This is, in this case, passing through a point P at t is equal 0. You see, that's a flow, okay, which pass at a point P. The initial is a point P, okay, at t is equal 0. The point Q is phi of eta is reached after time eta along the flow. The goal is to compute the Lie derivative. This is the definition of the Lie. This is a sign of definition. You see, double dot here is equal. This is the limit eta goes to 0. This here is the push forward, as you see there. Minus y at p divided by eta. That's a limit. Okay. Now, y tilde of p is the vector y evaluate at q and pushed back to point P. As you see over here, okay, that's vector y, which is pushed back to the point P. This is denoted as y tilde. This is red one, you see? So the vector field xi is defined of dxy over dt. Xi is a local coordinates, you see? So this vector field generates the flow phi of t. This is a phi of t. That's the flow, you see? Now, on the other hand, yi is dxi by d delta. D delta is another parameter, okay, analogous to parameter t, okay, just to a tangent vector, see, down the curve, which delta is auxiliary parameter. So, auxiliary real parameter delta. So this is p, that's q, that's eta. Tp is equal 0 is the orange, okay? The orange of this is a real space, is a scalar, okay? That's eta is this case, the coordinates at tq. Now eta is tq minus tp. Tp is 0, so eta is equal tq. tq is greater than 0, you see? So that's I think we did this before, but I'm repeating. Now this is step 1, you see, and over here this is step 2. This figure here it's important because this is phi of 0 is a point P, is phi of eta is point Q, and T belongs to the reals, the space. Now, step 2, we're going to compute the push forward of YQ. You see, again, I will insist in say that we'll not use the pullback, we'll not use the adjoint identity, you see. That's to lead what I want. I'll just use the push forward of YQ. That's why the derivation, you see, is quite simple, as I said before. So, this is the push forward, the phi of minus eta, you see, acting on YQ, this pushback YQ to the point P. Okay? That's what you call the push forward of YQ. Now at P, as I said before, is phi of 0, is xj at P is a local coordinates. Likewise at Q is phi of eta is xj of Q, also local coordinates. You see next lecture 9b the meaning of the differential d phi of minus eta. You see, I'll explain the reason for this, okay? So don't miss it. So I'll see you on next lecture 9b. That's it.